3, 2. Ah, my writing. 3, 2, 1. I hope it doesn't hit any live wires. Go! Left. Okay. Stop. It took like 2 seconds. The highest point took 2 seconds, and it took nearly 3 seconds to go down. 2 seconds for the highest, and means that we would have 4 seconds. First one. I can guarantee you there will not be any cutting. So let's reset that. I'm going to put my writing apparatus down. We're going to get the ball again. Okay, 3, 2, 1, go! Let me just write that down. So I lapped it. So that's like split. And it's like 3 seconds for the entire duration of the event. Alright. So second test run is 1 second going up to the highest point and 3 seconds for the entire thing. Okay, so quick pause because there were so many people just walking around. Put your writing apparatuses down quickly. This is a really small window of time. 3, 2, 1. Start. Lap. Stop. 2 seconds. It was 2 seconds, but for the highest point, it reached what? For the highest point, it reached a second, so 1 second. And then we have 2 seconds for the entire duration of the throw. Last point, we have 1 second up and 2 seconds for the entire duration. So that's the entire experiment. So earlier, for the recorded time, we had 4 seconds for the first run, 3 seconds for the second run, and 2 seconds for the third run. It says here in the activity that I'm going to have to divide it by 2 to get the time which the ball was in the highest point up in the air, assuming you know. So 4 divided by 2 is 2, 3 divided by 2 is 1.5, 1 divided by 2, 2 divided by 1, 2 divided by 2 is 1 second. And I'm going to have to get the average, which is... So I just got confirmation that in finding the initial velocity of activity 3, we are to use the initial velocity of 0 meters per second, as it is instantaneous. So let's write a new one. I'm gonna put all the given I have here. If you remember, I have 3 sets of the givens right there. Find a pen later. But the given is, let's do the first one. And what we're gonna do is we're gonna get the equation. So what we're given is, instead of a negative -9.8 meters per second squared as the acceleration. We're doing activity 3 here, so like, since it's instantaneous, the initial velocity of the ball using the formula VI is equal to VF plus A multiplied by T, which is acceleration multiplied by time. So what we're finding here is actually the final velocity.
since we have VI is equal to VF multiplied by T, and our given is acceleration is equal to positive 9.8 meters per second squared, and our time would be, the time would be 4 seconds, as stated here on the board, 4 seconds. Time would be 4 seconds, and initial velocity would be about, initial velocity is 0 meters per second. So that's our given. This is the first equation we're going to use, if you can see that clearly. So, first equation, we have the equation here. What we're going to do is we're just going to fill that up with our given data. So VI is also known as 0 meters per second is equal to VF, because we don't have the final velocity, plus acceleration, which is 9.8 meters per second, and time, which is just 4 seconds. 4 seconds. Meters per second for the acceleration. We got that. Bada bing, bada boom. As you can see, I've kept the little units here because what we're going to do is we're going to do a little bit of dimensional analysis on the side. Now this is mostly going to be multiplication and addition, so I'm just going to solve it as is with VF being on here plus so it's going to be 9.8 meters multiplied by meters per second squared multiplied by 4 multiplied by seconds. This is just so we can do a little bit dimensional analysis. And then we're going to have VF plus combine like terms, so 9.8 multiplied by 4 multiplied by meters per second squared multiplied by second, which we're going to turn seconds into a fraction because meters per second. So turning that into a fraction means we're just adding a 1 as a denominator, which is how you do it in fractions. So VF, just do it accordingly. So I have 39.2, if I'm not mistaken. Hold on. Okay, so I tied up my hair a little. So I multiplied 9.8 by 4. I know it's looking a little, I turn into an asterisk so it doesn't look too confusing. But then we're going to conduct dimensional analysis, treating them like algebraic expressions, I think, is what Sal Can has taught me. So, and my teachers. Actually, no, I was never taught dimensional analysis, but yeah, taking Algebra 1. Okay, so for this one, we're going to have to cancel second squared in seconds, because they're essentially the same unit, just expressed differently. So we're going to cancel second, and we're going to cancel that exponent, because it's just going to be 1 second. So what we're going to be, and then, multiply, as we're cross-multiplying it, so multiply m to 1, so it's 39.2 meters per second, meters per second, yeah, meters per second, multiplied by meters per second. You could also take off the multiply, I'm just kind of doing it so it's not obvious. So VF plus 39.2 meters per second. Now what you'll notice is that we can't really combine like terms, because VF and 39, well actually we can combine like terms, which is what we're going to do, but you can't add these two because they're different units. That's wrong. You don't do that unless you don't have like a good explanation or something. But since you're adding these, what you're going to want to do is you're going to have to I guess you're going to have to equate, or you're going to have to move VF over there and 0 meters per second over here. So VF is equals to 0 meters per second plus 39.2 meters per second. You'll notice that they both have the same unit. Now that's good. We're just going to conduct. Then we're just going to conduct addition. So 39.2 meters per second is equals to 39.2 meters per second. And that is equal to the final velocity from that. That is equal to the final velocity, which means we have a final velocity. Next thing we need to do is to solve for the maximum height of the ball. And imagine the time, okay, velocity. So we're calculating for the final velocity, so yeah. We're gonna have to get the maximum height reached by the ball using the initial velocity. Are we gonna use the time? I'd imagine, since, we're finding maximum height here. We're still on number 2. Number 1, I meant the first trial. I'd imagine since we're calculating for the maximum height, before it's said to divide the given duration of the throw and divide that into 2 to get the time that was the maximum, or like the highest point of the throw. Whatever. It's not like there's anything different. So that is the time we're going to use. We're going to use this time instead of this, because this would indicate the entire throw. So using this would mean we're calculating the distance of everything, but we're looking for the maximum height. So what we're going to do is I'm going to add this equation. So I'm just going to do first ball throw. First ball throw, I've already spent 9 minutes. Alright, so let's just speed run this. Equation is D equals the velocity, initial velocity multiplied by time plus 1/2 multiplied by acceleration and time squared. So just filling up the given. Alright, we have D on there. We have the initial velocity, which is 0 meters per second, multiplied by time, which is not 4 seconds, which is 2 seconds. That's 2 seconds, because we're calculating the maximum height the ball reached. Alright, so that's 2 seconds plus 1/2 multiplied by the acceleration, which is 9.8 meters per second squared, multiplied by time squared, so 2 seconds squared. That is the solution. Then we're just going to conduct multiplying, so 0 multiplied by 2 multiplied by meters per second multiplied by seconds, since we both have seconds in there, and the first second is going to be a numerator. The meters per second one has the seconds for the denominator. That's going to cancel out. We're going to be left with the unit meters, which means we're going to have, for that one, we're going to have, for 0 divided by 2 is 0, so we're going to have 0 meters plus 1/2 of 9.8 meters per second. 1/2 of 9.8. 1/2 multiplied by 9.8 meters per second. 9.8 multiplied by 2 multiplied by meters per. Actually, no, it's PEMDAS. So actually, we're gonna have. Actually, that's wrong. This one's going to have to be 4, because it's squared. So it's gonna be 9.8 multiplied by 4 meters multiplied by 4 meters per second squared multiplied by meters per second squared multiplied by seconds squared, which means for, we're going to put 1/2 over there. We're going to put 9.8 multiplied by 4. We already had that, so we have 39.2 meters per second. So it would be 39.2 meters per second squared multiplied by meters per second squared multiplied by seconds squared. Now what we're going to have to do is that the second squared is going to have to cancel out because we have 2 of those, so we're just going to be left with meters. Next is 0 meters plus half of 39 point, okay, so 1, oh my god, 1/2 multiplied by 39.2, 39, oops, 39.2 is equal to 19.6 meters. 19.6 meters, this is going to be 19.6 meters multiplied, 19.6 meters plus 0 meters is equal to 19.6 meters is the maximum height of our thing. So that's going to be the distance for the first one, and it's going to be the final velocity for the first one. That's where we're going to go to the second one. Same old, same old. So I'm just gonna, I don't know, whatever, let's speedrun it. Second throw, we have 3 seconds on the docket and 1.5 as its half, so we're going to go with the same. Given is still it's equal to 9.8 meters per second. Time is equal to 3 seconds. And initial velocity is still 0 meters per second because the throw is instantaneous. Therefore, we start at rest. Okay, solution. Equation is VI equals to VF plus 8t. Alright. Solution, we still get, solution is 0 meters per second is equal to VF. VF plus A, which is 9.8 meters per second multiplied by meters per second squared. Don't forget the squared if it's acceleration. Multiplied by 3 seconds. Alright, VF plus, okay, we have 9.8 multiplied by 3 multiplied by meters per second squared multiplied by seconds. Alright, just type that bad boy in. 9.8 multiplied by 3 is going to be 29.4 VF plus 0 meters per second, 0 meters per second. VF is equals to just a little dimensional analysis of what we did over here. So that other second is going to cancel out. We're going to be left with meters per second. So we have 29.4 meters per second. 29.4 meters per second. Combine like terms. So we're going to leave VF outside here. Actually, there's one thing I kind of skipped over. Because if we put VF over there, what's going to happen is that just let's just put VF over there is equal to 0 meters per second plus 29.4 meters per second, same unit, equals to 29.4 meters per second as the final velocity. Alright, 29.4 is the final velocity for the first one, and then we have the other one. The given is going to be 1.5 as time as we are calculating the maximum, like the point of distance. Alright, so once again the equation is going to be d equals to vi, which is the initial velocity, multiplied by times plus 1/2 multiplied by acceleration multiplied by time. Come on, fill in the gap. Vi, 0 meters per second, multiplied by time, which is 1.5 seconds. Next is we're going to have 1.5 seconds, we're going to have 1/2. 1/2. Acceleration is 9.8 meters per second squared. And it's going to be time, which is 1.5 seconds squared, because that's in the that's in the formula. So what we're gonna do is dimensional analysis. Be 0 meters. 0 meters is you're multiplying 1.5 with 0, and the seconds cancel out, so we're gonna have 0 meters. 9.8 multiplied by 1.5, let's go 14.7. 14.7, the seconds, oh, that's wrong, so we're gonna have to follow PEMDAS. So first is of course exponent, so 1.5 squared is 225. 2.25 is multiplied by 9.8. It's going to be 2205. 2205. And then the second squared, and the meters per second squared. The second squares are going to cancel each other, right? So we're going to be left with 22.05 meters. We're just going to get the half of that. Divided by 2. Oh, it's going to be 0 meters plus 11.025 meters. So 0 meters plus 11.125 meters, which means 11.025 meters is the highest point, aka the distance of the second throw. Let's go. Last one for the homie DJ Screw. We're going to have given. So the given is 2 seconds. The given time is 2 seconds. Time. And as always, acceleration will be positive 9.8 meters per second squared. Initial velocity is going to be, VI is going to be 0 meters per second squared. No, just 0 meters per second because it's velocity. And because, throwing it up, it starts at rest. So that's the initial velocity you're working with. It's the initial velocity you're working with. Let's go back to, so we're on the third, hold on, I'm just going to cancel those other 2 out. Yeah. So we're on the third throw, which is the third recorded throw. So, we had 2 seconds as the entire duration of the thing. So, VI equal to VF plus A multiplied by T equal to 0 meters per second equal to VF plus 9.8 meters per second squared. The time, which is 2 seconds, and as such, so VF is going to be Now, dimensional analysis 9.8. 9.8 multiplied by, hold on, 9.8 multiplied by 2 seconds is equals to 19.6 seconds. Is going to cancel out seconds squared, so it's just going to be left with meters per second. So we're going to have VF plus 19.6 meters per second with the 0 ms outside. Over there, we have that one. Yeah, right there. Different meters outside, and then what we're going to do is we're going to combine like terms. So VF is going to go outside the other side of the equation. We're going to pull 0 meters per second back so we can add those two. Because 0 meters per second plus 19.6 meters per second. Since they're like terms, we can add them. So 19.6 meters per second is our final velocity. Let's go. Next we have the distance of this thing. We need to go. In case you want to see, that's the velocity of the third one. Second, third. I'm just labeling them so I don't get confused later when I compile all this data into one comprehensible table. So we still have same VI, same A, different time. Because we're going for the maximum. We're going for the maximum point, which is, we're going to have 1 second as a time. So distance is equals to initial velocity multiplied by time, multiplied by time plus 1/2 of acceleration multiplied by time squared. Dude, I already have the formula memorized. So let's check if my formula is right, which is, it is right. So now still same given. Let's start, that one. Let's start substituting things we need. So initial velocity is always 0 meters per second because we did start with rest. Time is 1 second. 1 second plus is just 1 sec. So 1 is just second. I just forgot the C, and then 1/2. 9.8 meters per second squared. Sorry, that was disgusting. So have T squared, which is going to be 1 second squared. Okay, so 0 meters. I'm going to have 0 meters. Dimensional analysis, 1 second, 0.ms multiplied m over s multiplied by 1 second. Seconds are going to cancel each other. 0 multiplied by 1 is 0, so we're just going to be left with 0 meters plus 1/2 of, okay, so we have 9.8 meters per second squared, right? So we have 9.8. We have to multiply it with the squared version of 1. So 1 squared is still 1 going to be, right? So 9.8 multiplied by 1 is equals to 9.8, and then m over s squared multiplied by s squared. S squareds are going to cancel out. We're going to be left with n. So what we're going to have to do is going to be as 2. So it's going to have to be 9.8 meters. Just 9.8 meters, still kind of being like multiplied with like 1/2. So like, that's cool and all. So 9.8 multiplied by 1/2, aka 1.5, is 4.9. 4.9 plus 0 meters. 4.9 meter per second 4.9, no, 4.9 meters plus 0 meters is going to be 4.9 meters as the height of our little thing. Alright. I don't know. That's. Alright, 4.9 meters is the distance. Alright. Started losing myself there. And of course, we're going to have to solve for the average. But this is the average one. This bottom value, the average one. So we still have one more left to go. Let's go. Let's go. We got, of course, the formula, the given. We still know the given. So the formula is going to be VI equal VF plus A multiplied by T. Let's go. All right. VI is 0 meters per second squared. Y'all already know VF. We don't have anything to substitute for that, so it's just going to be BF. Next, we're going to have acceleration. Acceleration is always 9.8 meters per second squared because we're going down. We're breaking through gravity, and gravity's acceleration is 9.8 meters squared. I guess the absolute thing. All right, and then we have T. T, what is time? The time in our average is 3. The average is 3. All right, so time is 3 seconds. Over there, this is the last one. This is the average. Average. This is the average one. All right, we have those. And we got 0 meters per second, and then equals VF plus dimensional analysis. I already did this one, which is 9.8 meters per second. 9.8 meters per second multiplied by 3. It is 29.4. So we got 29.4 dimensional analysis. We're going to have to cancel that other second. So it's going to be meters per second. No square, just meters per second. 29.4 meters per second. We got 0 meters per second outside. Change them. VF is going to be 0 meters per second plus 29.4 meters per second. Same unit. Let's add. It's going to be 29.4 meters per second is equal to our final velocity. All right. Let's go back to the maximum height of the distance. So we're going to go with the formula of D equals initial velocity multiplied by T plus 1/2 of 1/2 multiplied by the acceleration multiplied by T squared, which is T stands for time, by the way, just in case y'all forgot. VI, initial velocity, is always 0 meters per second multiplied by time, which is, of course, the average of the time. So we're going to have to go with 1.5 seconds. So 1.5 seconds. We've already done this thing. So the average is literally 11 point. We already done this over here. Like, this is the same thing. Alright, do I need to spend any more time doing this? Because that means the average we got is 29.4 meters. Hey, the average of the maximum height is going to be 11.025 meters. And that's the average distance. So we're just going to have to create the table. I know, I'm going to have to create the table quickly. This is the table. We got the trials. We got trial 1, 2, 3, average. We got trial 1, 2, 3, average. It's a very crude, well, table. I do apologize for that. But we're in a bit of a time crunch here. We're going to go with the velocity of each and every one of these guys. So meters per second. Velocity is going to be, Alright, let's start with the average because it's the closest one here. The average has a velocity of 29.4 meters per second. So 29.4 meters per second. And number 3 is going to have the velocity of 19.6 meters per second. 19.6 meters per second. Number 2, trial number 2 is going to have the velocity of 29.4 meters. 29.4 meters per second. And the first trial is going to have, excuse me, my bad, the velocity of 39.2 meters per second. 39.2 meters per second. That's all our given velocities, if you can see. Next, we have the max height, or just the height actually. Height, which is expressed in the unit of meters. So once again, we're going to start with the average height. Average height is 11.025 meters. Next is the average height of trial 3, or actually not the average height, sorry, I meant like the maximum height of the ball in trial 3, which is 4.9 meters, and we're gonna have number 2, which is 11.025 meters. Then the max of the first one is 19.6 meters. 19.6 meters. These are very good throws. And that is our table, everybody. Is it focusing? Is it focusing? Focus. Focus, please. And that is it for activity 3. Bye-bye.